So good morning, everyone. Will you please join me in welcoming our next speaker, Andrew Hill from Textile?
Thank you. Hi, everybody. I'm here to talk to you about IPFS. I come from a company called Textile. We build a suite of tools to help developers create totally custom, decentralized, resilient applications on IPFS, and a platform to help developers give users greater access and control to the data that they create. I really was excited to present IPFS today because I think if the future plays out the way that we're seeing it, IPFS could have a really big impact on the way that we build mobile applications and consumer applications, potentially as big as the other large concepts that you're seeing around AR, VR, machine learning on device. And so I wanted to share that with you today. I'm guessing that not many people in the room are familiar with IPFS, or at least have built IPFS or joined the network with a peer before. And so I want to start kind of at a little bit of a meta level before we get to running it on device, just to get everybody caught up that maybe hasn't heard of it before. So the first point that is worth bringing up when thinking about IPFS is that we're building applications on a very centralized web right now. It's centralized kind of at both layers of the stack. Consumer centralization is greater than ever. You see 1 billion people in Instagram, 1.5 billion people in Gmail, 100 million Alexa devices. But then underneath those are all the developer tools that we touch almost in every application that we're building that collectively have even larger numbers of users touching these central points. And such great centralization on the web can cause a lot of pains. It can have really big implications at a technical level, and some that some that hit you in the face when applications or these central points of technology sunset, for example, and the apps that we've built depend on them, then break, and we have to figure out new solutions. Or the ones that are probably more nefarious but less obvious, things like link rot. So there was a really great study that, I forget the year, but it showed how many Supreme Court statements had URLs in them and what percentage of those URLs no longer work anymore. And it was something like 70% over a really large time span. And that's really bad, right, if we're trying to collect and connect information. And building technology this way is really strange to me. It's like if you imagine building the DeLorean and having it not work anymore once the company folds. That's really odd, and that's funny that we're putting so many resources into building technology this way. So much centralization can have really big impacts socially too, and we're seeing this unfold on the web right in front of our eyes today. I'll give you one really good example of that. Wikipedia, the article on state-sponsored terrorism, mentions a lot of countries: United States, Great Britain, Turkey was in there or is in there. And the government of Turkey saw this as media manipulation. And so they decided that Wikipedia needed to remove them from the list of countries that had ever sponsored terrorism. And Wikipedia obviously decided not to do that. And so Turkey blocks Wikipedia now. You can't go to Turkey and use the internet like you would normally use the internet and look up anything on Wikipedia. And the reason I give that example, it happened two years ago. It's still going on today, but I'm going to bring this up in the story later. So I thought it was pretty important. And so IPFS is a project that was started thinking about the internet and thinking about these problems and how we could potentially just reconfigure the way that we're using the web. And so this is a really nice quote from the creator of IPFS and really frames the thinking. So IPFS has a really grand name. I love the name of it. It's the Interplanetary File System, and it really gets your imagination going. But under the hood, IPFS is a decentralized protocol and network for exchanging information, for exchanging data on the web. It uses, unlike HTTP, it uses verifiable data. It has resilient self-organization about how the network is put together. And it allows peer-to-peer communication at large and small scales, no matter what the network outside of that peer-to-peer communication looks like. Oop. IPFS offers us a lot of new ways to think about how we're doing mobile development. Global scale peer-to-peer, it's really exciting. IPFS itself isn't by default encrypted, but when you're building things with IPFS, you think about encryption and using it end-to-end. And unlike encrypting data as it goes through the pipes, you often think about encrypting data at rest, which is a really important way to start thinking about data. The distribution and resilient storage of data, censorship-resistant content in your applications, and for my project and our work, what we're really interested in is new models of giving ownership of data to your users. So if you haven't dug into IPFS before, there's so many cool concepts inside of it, and I don't have time to go over all of them, but I'll give you one linchpin of it, and that's content-based addressing. So the web today, as you usually use it, uses location-based addressing, which is you have something that you want to get off the internet. It has a URL and a path. You go figure out what the server is for that URL. You go to that server, give it the URL. It finds the file and gives you the file. And this gives a lot of places to break. The domain could be censored. The server could shut down. The link could go, or the file could go away. And so that's exactly what happened with IPFS, right? You try to go get it in Turkey, and the government says, no, you don't get it. There's a new way to do this with IPFS, or it's actually not super new, but it is in IPFS, called content-based addressing. So instead, you take that same file, you give it a unique key, a hash. Here we use SHA-256. That key can only exist for this file, theoretically. And so if you know the key, you know what you're asking for. And then you just ask the network for that thing. And this is a really quick, hand-wavy explanation for how this works. You ask the network for that thing, and if anybody on that network knows what that thing is or has it, or knows how to get you to somebody that does have it, they'll get it to you. And so you ask for this fingerprint, and you get that same JSON file. And when the person who's serving that to you gives it to you, you know that they gave it to you because you just have to rehash it, and you'll get the same fingerprint. So same case, you go and you try to get Wikipedia, no. But I really quickly showed this before. The last really cool thing, which I can't go into in depth here, is that the person that you ask the file from doesn't necessarily have to have it. They know how to route you to somebody who else is more likely to have it. And so in that way, instead of going to the single source for Wikipedia, I go to the IPFS network. I ask for the page that I'm interested in. Somebody routes me to it, and the government has no way to stop me. They would have to go and shut down every peer in that network between me and the person serving it. And then when I get that file, I know that nobody's tampered with it in between because I can just rehash it, get the same fingerprint, and voila, I know what I asked for is what I got. And this is exactly what we saw, and this is why I brought the example of Turkey up, is that people are now running an IPFS-hosted version of Wikipedia, so people in Turkey can still read that website. That's really interesting for Wikipedia and really exciting for Wikipedia. Now imagine it for the data behind your app. It doesn't work as well. Wikipedia is open. Anybody can go, grab the content from Wikipedia, put it on IPFS, add these mirrors. But we need to think about how we do this for our own applications in different data sets. So let's add IPFS to iOS. That's something that we've been working on really quick, going through this. The reference implementation of IPFS is Go. It has no mobile APIs, mobile-specific APIs. So what we've done is wrapped the Go IPFS in a second Go library called Go Textile. And that adds some nice helper functions for mobile. We use protocol buffers to type everything. And then Go has a really nice module called Go Mobile. So you can compile Go modules into native libraries. So we compile a few different native libraries, including iOS Textile, which now has an embedded IPFS peer with some nice APIs that you can use from Swift or Objective-C. If you want to see the way that we're building this, it's all open source. I can share this with you after as well. And we just have actually continuous integration that's doing this, so you can see our build scripts right in the CI script. Some keys to running IPFS on mobile, we actually trim it down. So your mobile peer isn't one of the full nodes on the network. It only is a leaf. It's really only serving data that it has if somebody directly asks it for it, and it's only requesting things from the network. It doesn't do any of that thing I mentioned in the middle, which is routing other people to things, because doing that and some other pieces of IPFS make your phone burn up. So we don't do that. But OK, so then this is a really cool problem. How do you make a new data on the phone available elsewhere on the network? Because phones aren't servers. Phones fall asleep, or phones go to sleep, phones get backgrounded. And then how does the network find a hash that you're supposed to have? And it looks like this, right? So I have some cool thing I want to share on the internet. I get the hash, and I get you the hash. And then my phone goes in the background. And you go, OK, I want to retrieve that file, because I want to look at it now. IPFS can't find my phone anymore. So what we started doing is running IPFS peers that are trustless servers that will cache data in between me and you. So what I can do is take an encrypted file, throw it on one of these cafes, and my phone can go to sleep, and your phone can then grab it when it wants to. And what's really cool about this is that we actually expose both IPFS and the normal HTTP upload endpoints so that you can use background uploaders. And so we're sort of filling in all these really cool places around the network that make it so that it's actually functional on mobile devices. And it's making a lot of really cool things possible. If you want to do a deeper dive into this, we have a really nice set of blog posts about what's happening in IPFS and how this network is working and some of the implications it has on mobile. Some people are building really cool things. Healthcare, so doing peer-to-peer doctor communication where actually files need to be exchanged and you don't really want a server in the middle. Applications where you can use them with your data and you can be certain that the actual user interface and the UIs behind it will never sunset because you can actually control the data that's going into them. Or applications where you never want that data to go away. And I'm out of time, so if you want to check out more, we have some really cool documentations, and like I said, the blog post goes into some of the more technical details of the IPFS network. So thank you.
All right, we have just a couple minutes for questions, so if anyone has one, I'm sorry I can only pick like about 2 before we have to move on, but just raise your hand, I'll bring the mic to you. I already have someone here who's eager, so we'll get started with them.
Hi, are cafes in any way subject to like man-in-the-middle attacks?
Well, so no, not really. I mean, because that fingerprint for a file is really cool. So what we do is we actually, any data that's going between your phone and a cafe is encrypted. So the cafe never knows what it is. It's just some arbitrary data. And that encrypted blob actually gets its own unique fingerprint, the SHA-256. And anybody else who's trying to get that file will use that same SHA-256. And then they can just get it and look and see if it matches. And if it doesn't match, they know there was a man in the middle.
So my question is about if you know just generally what you're looking for, but you don't know the fingerprint of the item, is that still a limitation or a vulnerability where a search engine could be blocked or you can't find what you're looking for, you just have a general idea? I want to know about Turkey.
Yeah, that's a really new, well, it's a pretty new concept in IPFS, and there's a couple other teams and projects working on how to do search and how to add sort of rich metadata to the original hash. So there's another project called Interplanetary Linked Data, which lets you do more complicated data structures. You can have like folders and hierarchies, but also you can start adding rich metadata that makes it searchable as long as there's somebody indexing it. So.
We're out of time for questions, so I apologize. Feel free to reach out to Andrew after the talk, though, and ask him any other remaining questions. Let's give him a hand.
Thank you.